Chapter 1, Sinusoids. So in this chapter, there are a few important points that I would like the students to take note of. First one is, as the title indicates, sinusoids. So we will be looking at sine waves. So sine waves, they are usually represented in sine or cosine. And then next thing is, in this chapter, as well as the next chapter, we'll be looking at some operations of sinusoids. That means we might be adding a few sinusoids, we might be multiplying them and then seeing what we get from there. And next, what is important is we will be focusing on the time domain. Okay, so we will look at the sinusoids in time domain. After that, we will look at time shifting. And time shifting, we will relate it to the phase of the sinusoid. Then we will look at what is known as the complex exponential form of the sinusoids. And then what we want to get from here is the complex amplitude. And then this is very, very important because you will use this throughout the subject. So first thing is, let's do a bit of intro. So sinusoid or sine wave is usually expressed in terms of sine or cosine. So if you see in the expression you have sine something something or cos something something, it means that that term represents a sinusoid. So sinusoid is basically a periodic signal, and then it is also known as a sine wave. Okay, so this is the sine wave equation in terms of cosine. So we have a cos omega t plus pi. So a is the amplitude, and then omega t is actually 2 pi ft. Okay, omega t is 2 pi ft, which is also equals to 2 pi t over capital T. So the capital T here is actually the period, and then f is the frequency in hertz, and then we have frequency known as angular frequency, which is given by omega. So omega is equals to 2 pi f, and then pi here that you see in the last part is actually known as the initial phase shift. Okay, initial phase shift. So the other important thing is frequency is actually 1 over period. Okay, 1 over period. So next we look at sine. Okay, so we can actually convert sine to cosine. So there is one exam formula sheet given in Canvas. So I would like all students to refer to it and then be very familiar with it, because you will use this for your tests as well as the finals. So tests and finals make up 65% of the total grade of this subject. Okay, so a sine omega t is actually equals to a cos omega t minus pi over 2. So pi is 180 degrees, and then 1 period actually represents 2 pi. Okay, 1 period, 1 whole cycle represents 2 pi. So here sine omega t is equals to cos omega t minus pi over 2, or minus 90 degrees. Then we have a sine omega t plus pi. So we can rewrite it as a cos omega t plus pi. Then we have to include this part, minus pi over 2. I would prefer that the cosine to be represented as positive cosine. That means I don't want to see a negative sign. Okay, negative sign in front of any cosine term. And then if you have expression in sine, try to convert it to cosine. Okay, try to convert it to cosine before you proceed. So next is we try to relate the phase to time shift. So here if we zoom in a little bit, so we have a cos omega t plus pi. So we can actually rewrite the bracket term into Okay, we can rewrite the bracket term into omega t minus t1. So the t1 here is actually some form of delay or advance. Okay, it's time delay or advance. Advance means that it's before 0. So when we have minus t1, it means this happens after 0 seconds. So if we have t plus t1, it means that we are expecting this to happen before 0 seconds. Okay, before 0 seconds. So here we take the bracket term omega t plus pi. So we express omega t plus pi as equals to omega t minus t1. So here, after we expand this part, we get omega t minus omega t1. So we can remove this. So then we are left with pi. So pi is equals to negative omega t1. Okay, negative omega or minus omega t1. So here we can, if let's say we want to find out what is our t1, so our t1 is actually equals to pi divided by negative omega. So this t1 is important because for a cosine, okay, cos, whenever we have cos 0, we expect that the peak will occur at, okay, the peak will occur at time t equals to 0. But when we have a term like this, we know that the peak will not occur at 0. So this is one way for us to find out where the peak actually occurs. Okay, where the peak actually occurs. Okay, next, when we have to plot a sinusoid, okay, we have to relate the phase to the time shift. So here, let's say we have one example. So this example is 5 cos 0.3 pi t plus 1.2 pi. So how can we draw this? So here, first thing is we look at this equation. So amplitude is equals to 5. Then the next thing is we have to look at the frequency. So from here, the frequency is given to you as 0.3 pi. So the 0.3 pi is actually omega. Okay, so omega is actually 0.3. So omega t we have 0.3 pi t. So we relate this to 2 pi ft. So here we try to solve this. So 2 pi f is equals to 0.3 pi. So we can remove the pi. So here we find that our f is actually equals to 0.3 divided by 2. So we actually have 0.15 hertz. Okay, 0.15 hertz. So after we know what is the frequency, next thing is we can find out what is the period. That means one whole cycle, either this or this, how much time will it take? Okay, how much time will it take? So here what we find is our f is equals to 0.15 hertz. So our period will be 1 over f, which is 1 over 0.15. So we will get 6.67 seconds. Okay, so 6.67 seconds. So when we draw, we try to draw a few cycles. Okay, we try to draw a few cycles. That means we try to draw a few periods. So if our period is 6.67, let's say we want to draw 4 cycles. So we get 4 times. So we use the time 4 times 6.67 seconds. Okay, next is in our drawing, we want to show where does our peak occur. So what we do is we relate 0.3 pi t plus 1.2 pi to 0.3 pi t minus t1. So we try to find out what is t1. So from here, when we expand this, we will get 0.3 pi t minus 0.3 pi t1. So we have the 0.3, 0.3 remove off. So we get 1.2 pi equals to negative 0.3 pi t1. So here we find that our t1 is actually equals to negative 4 seconds. Okay, negative 4 seconds. So it means that our peak actually occurs at negative 4 seconds when we draw our graph. So in this subject, you will mainly use MATLAB. Okay, you will mainly use MATLAB to do the calculation and to draw all the graphs. So I encourage all students to really try it. So here I am using MATLAB Mobile. MATLAB Mobile means that I'm installing this in my Android phone and I do the simulation in my mobile phone, okay, or on my mobile phone. So if you have a laptop, you are advised to, or you should, okay, install MATLAB into your laptop or your home PC. And then please follow the guide that is already posted in Canvas. So try to find lab 1. So there are instructions and slides that contains the license or the serial number or license key that you will need to install MATLAB. So to plot these sinusoids, okay, so I set the time. So I set the time to show me about 4 cycles. So that's why we need to do some calculation and planning before we proceed. So I let x be the 5 cos 0.3 pi t. Okay, so I forgot to put here f is actually equals to 0.3. Okay, so then I ask the system to plot it for me. So here, after getting the result, I use the marker. So I'm able to find that at around negative 4 seconds, I can actually get one peak. So this one actually fulfills what is specified in the equation. Okay, what is specified in the equation. So next, okay, so next thing is we can actually examine where the peaks occur. So one of the peak actually occurs at negative 4 seconds. So if we zoom in, okay, so we can actually find one peak at time when time is equals to negative 10.69 or roughly negative 10.7 seconds. And then this is the one that we have just now. Okay, so it's at negative 4 seconds. And then then this one is at 2.67 seconds. Okay, 2.66 or 2.67 seconds. So here what we can find is the time spacing between one peak and the other peak is actually the period. Okay, so here they all come from the same equation. So we can expect the peak at another period after this. We can also expect a peak before, okay, before this point that we use for our based on our calculation. So every period you will get a peak. Okay, after every period you will get a peak. So here sometimes we call this 2 pi, or we call this a full wave. Okay, a full wave. A full wave means a full cycle. Okay, a full cycle. So next is once we know how to plot a sinusoid, the other thing that is important is that we need to interpret. Okay, we need to interpret a sinusoid. So how do we interpret this? So the first step is we look at the sinusoid. Okay, so we look at the graph that we are given. So first step is we try to find what is the amplitude. Okay, amplitude. And then next is we find what is the period. Okay, So we try to locate one cycle, where it starts, where it ends, and then we specify, then we look at the time, then we write down the period, so how many seconds does it take. Then from here we find out what is the frequency. So once we have the F, so we can find the angular frequency omega. So omega is equals to 2 pi f, okay, 2 pi f. So next is we try to find the phase. So how do we do this? So first we locate the peak closest to 0 seconds, okay, at 0 seconds. So the peak closest to the 0 seconds. Sometimes this can be a positive value, sometimes this can be a negative. If let's say we have a peak here, and then this is where 0 is. So what happened is our peak, let's say this might be 1 second. So if let's say we have a peak, but the peak occurs here, and this is where 0 is. And then this value that we get maybe is -2. So what happened here is this t1, okay, will be equal to -2 seconds. So main thing is we try to locate where is the peak, okay, record the time whereby the peak occurs. So we try to choose the closest one. You can actually choose another one, okay, but it should be close, but use the closest one because it's easier, okay, it's easier. Then next thing is once you have the time, you use this to determine the phase, okay, you use this to determine the phase. So just now we actually have the equation pi is equals to negative omega t1. So once you have the time t1, you can find out what is the phase. Then last step is to put everything together into this form. So you have the amplitude, you have the frequency, then you have the phase. So write it as a cos 2 pi ft plus pi, okay. Now this is one example to interpret the sinusoids. So when we talk about interpreting, it means that we want you to give us the equation to represent the sinusoid. So here first thing is we find the amplitude. So amplitude means that this is the positive swing starting from 0, okay, starting from 0. So here we find that the amplitude is equals to 5, okay. And the next thing that we try to find is the period. So here I choose from one now to another now. So and then I calculate this time, okay, I calculate this time. So time is 6.7 seconds. So I substitute f is equals to 1 over capital T. So I have this is roughly 0.15 hertz or maybe 0.16 hertz, okay. The next thing is we try to find the closest peak. So here there are actually two peaks, okay. So I choose the closest one, and then this is where this dotted line is where 0 occurs. So this amount of time is the time that I will be using to calculate pi. So here from this I find that I use the cursor. So I find that the time is 2.657 seconds. So once I have this, okay, so I can substitute into this formula. So pi is equals to negative omega t1. So I find out my t1 is 2.65, okay, 2.65. So then based on the frequency, I have 2 pi times 0.15 hertz, so I get 0.3 pi. So I multiply negative 0.3 pi with 2.657, so what I get is roughly 0.8 pi. So this is the equation. So I have 5 cos 0.3 pi minus 0.8 pi. So you can actually see that this graph is the same as the one that we used just now. But what happened here is we are using the time, okay, the time shift, which is t1. So we use the T1 that is closest to 0. So we get this version of the equation. Okay, we actually get this version of the equation compared to 5 cos 0.3 pi t. Okay, just now was plus 1.2 pi. So you can see that 1.2 pi and negative 0.8 pi, the difference between this pi and this pi is actually 2 pi. Okay, that means 2 pi or 1 whole period. Okay, 1 whole period. So this is one exercise. So try to write out the equation if we are using the peak at negative 10.69 seconds. Okay, so here what happened is with the same graph, okay, we can actually get different equations. Okay, so we can actually have different equations, and then they are buried just in terms of the phase. So here what happened is we call this having ambiguity in phase. Okay, ambiguity in phase. That means the phase can actually take different values. So this is one consideration, or you can treat it as one exercise that you might want to try. So let's say if we have a new signal yt, it is produced by squaring xt. So we used the xt in the previous slides. Okay, in the previous slides. So try to express yt in cosine, and then find out if it is sinusoid. And then if it is, what is the frequency, what is the period, where does the peak occur. Then plot the time domain waveform. So you can try to plot this by using MATLAB.